All right, now this is second part of applications of vectors, and you're just dealing with different situations. So once again, drawing is essential. So Hector is walking his dog Fido around the neighborhood. Upon arriving at Fidela's house, a friend of Fido's, Fido turns part meal and refuses to continue to walk. Hector yanks on a chain with 67 newtons of force at an angle of 33 degrees above the horizontal. Determine the horizontal and vertical components of the tension force. Alright, so here we have everything. So he's pulling up at this direction. Okay, so we'll be working with this one. So he's pulling on the dog this way. So obviously the components will be going up and up. The vertical components will be going up, and the horizontal components will go to the left. Okay, so if you look at it, it's a pretty darn nice right triangle. And yes, you can use right triangle trig to get there. Okay, so on this one, we would be multiplying both by 67. So 67 times sine of 30. Okay, and the vertical component is going to be equal to 33.5 newtons. Okay, and the horizontal component is going to be 58.02 newtons. Okay. All right. And so there's the vertical and horizontal components of my actual vector that's working in this physics problem. Okay? All right. And just remember, if you can make a right triangle out of it, make your job a whole lot easier, use it. You know, a lot of these really help when they're working with it. Okay, Helen is parasailing. She sits in a seat harness which is attached to a tow rope to a speedboat. The rope makes an angle of 51 degrees with the horizontal and has a tension of 350. So once again, this is determining the horizontal and vertical components of the tension force. Okay, so right here we have sine of 51 equals V over 350. But I get a little ahead of myself. So she's up here. Here's Helen. Hey guys, hey, it's parasailing. This is really high. It is, Helen. It's because there's a lot of force being acted to hold you down from the gale force winds apparently holding you up. Now this angle 51 is right here. So here's the actual boat down here. Okay, all right, and so the force being pulled on to keep her within holding distance is 350 newtons. Now I understand this is not going to be consistent. This would be more of a snapshot in time of this type of thing. Okay, and obviously as the degree lowers, we're going to have different measurements and stuff. Okay, so now looking at these ones right here, okay, so Helen's held right here, 350 newtons, pounds of force, 51 degrees. Okay, once again, right triangle trigonometry, vertical component is going to be, let me see, what is that? 350 times sine of 51. Okay, and that's going to be a nice sloppy number. I love, some of these are just cool. Okay, 272 newtons. Now you're probably wondering yourself, how many do I round to? Well, it's significant numbers is okay. I like to round to the nearest hundredth, and that one just happened to be 00, so I just left it as is. Okay, on this one, let me see. The cool thing is that on your calculator, you can just go back and just put in cosine instead of sine, and it will do the same thing. So this one's going to be 0.26 newtons. Okay, so the vertical and horizontal components are listed here. Okay, so that's how we just work with it. Just make sure you draw the picture, list your knowns and unknowns, and just work with it from there. Okay, now this one's going to be a ton of fun. Okay. All right, Jerome and Michael, linebackers for South's varsity football team, deliver a big hit to the halfback in last weekend's game, striking the halfback simultaneously from different directions with the following forces. The force of Jerome is 1,230 newtons at 53 degrees, and the force of Michael is 1,450 newtons at 170 degrees. Determine the resultant force applied by Jerome and Michael to the halfback. The direction of the two forces are stated as counterclockwise angle rotations of east. So in other words, 53 degrees will be something like this, and then 107 will be something like this, past 90. Okay, and let's draw a picture to see what we're talking about. Okay, so if we have the halfback going south, okay, let's just say hypothetically he's going south, okay, and then the two linebackers hit him this way, the force is going to drive him back 107 degrees this way at 1450 newtons and 1230 newtons at 53 degrees this way. Okay, so when we are drawing the actual resultant force, I would probably recommend do tail to tip. I would move this one over here. Now obviously I'm going to keep the original just because it will make sense when I'm trying to figure out the remaining angle and everything. Okay, alright, and then let's pick green. Okay, alright, and voila, I have the direction of my resultant force. Now, is this going to be a messy triangle? Yes. Are you going to have to use law of cosines, law of sines maybe? Yep, I'm not going to lie. So 1450 newtons. Okay. All right, now let me consult my notes because I actually had to draw it out and work with it. Okay, now this one right here, and this is the windrows I'm talking about. Okay, this will help you when you're trying to figure out the angles. Okay, the windrows, this is north, south, east, west, that type of thing. Okay, I know that this angle right here, has to be 107. So I know that's 107. Okay. All right, now down here, this angle and this angle, these are three angles, they make up 360 degrees. Okay, let me continue drawing this part out. Okay, let's pretend. Okay, that's an ugly straight line, but a trackpad on a laptop is really hard to work with sometimes. Okay, so on this one, if we figure out this angle right here, okay, and we subtract these two from 360, we'll get this inside angle, and we can use law of cosines to actually figure out the magnitude of this one right here. Okay, now you can't say, oh, it looks like it's 90 degrees, so subtract 53 from 90 and you get 37 and get 37 right here. That's not it because we don't know. It looks like it, but once again, I'm a crappy drawer and it just happens to look like that. Okay. All right, but we do know that this angle right here, if we were actually to draw it, okay, let's try to draw it a little bit. Okay, this angle right here is going to be the same as 53, so that's 53. So we know that's 53. And if that's 53, we know that it makes a linear pair with this other angle right here. And voila, look at this sweet thing. We got 127 degrees. Okay, and so this angle right in here is 360 minus 107 minus 127. Okay, which is going to be 360 minus 107 minus 127, it's just going to be 126 degrees. Okay. All right, so that gives me that angle in there. Now, I've kind of muddied up the whole situation, but I'm dealing with a triangle that looks like this. Okay. All right, so I know that this is 1450. I know this is 1230. And I know this is now 126 degrees. Okay, so I can use law of cosines to actually figure out this angle right in here. And I can also use law of sines to figure out the angle that's north of east. Okay, and when I use law of cosines, here, I'm going to click it over here. 2159.56 newtons. So if anyone tries to tell you that football is not an insanely combative sport, they are just dirty, dirty, dirty liars. Okay, now I did use law of cosines correctly because if you remember last semester, we talked about using law of cosines. You always want to find the biggest side first, which is always opposite the biggest angle. So there we go. Okay, that's it for applications with vectors. If you have any questions, feel free to talk to me because sometimes they're confusing. I'll talk to you guys later.